Итак, у нас начинается новый доклад. Выступает Stepan Danilov с докладом.
We're starting a new session. Stepan Danilov with the presentation of optimization of the optimized and not quiet. Thank you very much for your attendance. I have never made any presentations before. Thank you very much for your cheering, for applause. I work at RT Labs. I'm a developer and live in Kazan. There is a RT Labs department that produces automation in healthcare. We have one application, a regional medical application system. RMIS works on two platforms. From the side of database, one platform is ORM and the second platform is native. Along with this work, we have the task of optimization of options and SQL queries. Today, I will show optimization of real queries as mere examples. I will speak rather with the developers, but not all developers love SQL, and I think I will speak to the ones who don't love SQL, and I want to show you what the true love to SQL means, and I want to invite you to get acquainted with SQL. We regularly do not make tests on huge platforms, and I wanted to draft my presentation as introduction to optimization of queries. I will not show any complex analysis of plan of queries. I will now speak about indexes, and we will not speak about business logic of queries. Perhaps for some of you these are elementary steps, but we still need to make them, and I will tell you about the changes. Measurement of queries is based on explain and on the basis of analyze. Analyze says that we are speaking about the real time of execution, and buffers tell about the use of memory. We will not speak about plan of query. Out of the results of explain, we will need real time of execution, I/O timing, in and out, and buffers, memory buffers that are used for the execution of entry of query. The less buffers you have, the better. The first example, please. After a user opens the page, it sees the first execution time and timeout for the pages for 1 minute, and you have more than 50 seconds. Even at the secondary runs, reading time from a hard disk drive is more than 3 minutes. This is a complex query, and we need to take a look on its fragment. We don't have a code style. It is absent. In the fragment, I can see the most challenging queries in code style. Somebody writes keywords in the upper register. Someone would draft the whole query in the upper register. It doesn't play a role. The main thing is you need to read it quite well. Let's make it in one style. We have the differences here, and we need to rewrite them. The blank symbols. This comment does not have any sense. Perhaps if you use the system for version control, it's easy to change it. So let's get rid of the comments. The commas are chaotic. They can be at the beginning or at the end of a string, and the same can be said about operators and. So let's check it. There are many closing and opening signs introduced. I don't love them, so I get rid of them. Keywords join and inner join are equivalent. In one query you can delete left outer and just use left. It's easier to read. Logical blocks. You don't understand where the block begins and where it is at its end. So let's align them. After refactoring, it is easy to make an analysis of the query. We have two subqueries inside of the query. Then you can add additional filters, sorters, and limits for it. In block select, you can see columns and subqueries and calculations, results of them. It's union all. It's the union of all queries, but there are some specialists who prefer union and not union all. If you need only unique queries, you need to check whether you use union and all. Yesterday it was a similar case, and there was a question after it, whether we can limit every subquery by a limit and sort them and introduce a limit. Yesterday, I think we forgot why it cannot be realized. Why it cannot be realized? In my case, I can give you an answer because I also received here offset. How can you calculate and count when you receive offset 2 with a limit? Will it be more? So for how much? Still, but this is a complication of a logic and whether you really need to apply this or not. In this case, to transfer these parameters, you would work on the core, and we decided not to do this. To localize problem code, you need take everything simple out of the constants, of simple rows, simple functions, simple subqueries. In this fragment, you can see a case with many words. If you will translate it into Russian, when the condition is true, then it's true, or else it is false. But if you simplify this as a subquery, you are just asking whether the condition is executed or not. In the second fragment, we see alias ID. You use only one table, but then you use only alias. It's redundant for this case. In this fragment, birth date is compared with two dates, with the data out of parameter and running date, so you can rewrite it through between. For the current date, there is a function in Postgres, current date, and the text in such format will be then automatically processed. And you can make it more. You can make it easier. So birth date more or equals this date, the particular date. In the second fragment, there is too complex construction for concatenation of address. You can make it easier through concat ws. So at the end, you arrive at a simpler calculation. In this, you see the calls that comprises two subqueries. In each, you have a limit of one entry, and there is only one difference here: is main or not. And alias is has another wording here. So in the beginning, you take everything out of isMain, and if there is no isMain, you can choose anything else. Let's make it as only one subquery. Add sort by isMain. Here you can see that in cases when we don't have any entry out of isMain, we will execute only one subquery. And in the previous draft there were two subqueries. Let's get rid of the direction of sorting and additional alias. That is also redundant. We don't need it. In this fragment, there is a subquery that returns a column from the table, a row from the table that is made by left join. If we receive no data back, we will receive null, but the same will be at the join. So let's get rid of left join and leave only join. Here we have several left joins, and in block V to the rows of the tables there is only one. There is only one possibility. We need to take it out of block V into the join. And let's change where by join. And put it up as high as possible. We can also change to the join in the tables that were logically before the first join. Here we can see additional left join with MD appointment table. But if you take a closer look at the script of creation of a table, you can see that source ID field is not null. Then we are making it strict and put join as high as possible. In this fragment, we see a join with tables without any rendering of data to select. We can put them into exist, and here we are closing the redundant left joins. In this fragment, we see that resource ID is tested through in, and the subquery does not depend on the query itself. And here we can transfer it into CTE and then join it with CTE by a strict join. Please be careful while you apply CTE. You need to make additional checks because CTE needs more memory, and here you can add imperative qualities into the declarative language of CTE. Here on the diagram we see that the speed is decreased 100-fold. Now it is executed by 2.5 seconds. It also uses not so much memory. It is cached, and it is not read from the input devices. Now let's take a closer look on the next example. This query runs very often, and it is in the top of PGBH report. It is executed for 3 seconds, and it has in it 26 strings. Now let's cope with the problem. Let's delete all simple columns, the rows, and then we delete all the rows, and if the performance is not changed, let's do it more and more. But I think you need to check your actions every time you change something. Check the results. Out of the rows, we have only one last point. Only first table is used in this query, and we can delete this query, and we can delete limit, and we don't need to sort these 26 lines. It doesn't affect the performance. Now we see that the query is looks more simple. Let's take a closer look at bit between. We take 9 first symbols of a string, and the result is then driven to big int. Then you see the diapason and check it. But for this amount, you don't need big int. You can use only 4-byte integer. To calculate this number, you only need when the diapason margin is 9/10. So let's add this condition, and then we add condition into the primary query, and let's start it. We've optimized the time 15 milliseconds against the initial 3 seconds. Then, when we got rid from the redundant checks, we arrived at the better execution time. Let's go to the next query. Query number 3 is also a part of top report from PG budget related to the time of execution. It's very oft, and it is executed for at least 2 seconds, almost 2 seconds, and it uses memory. It is generated by ORM Hibernate. ORM queries are not read very well due to alias and due to many lines. The problem is localized according to the same scheme. We are just deleting the connections and rows that are not needed for this particular case. Sorting limits are also deleted if they are if they become burden for your entry query. Then we read alias, and there is only one write join. We have it in ORM. ORM did write it because manually you are not writing like this. So then change it to left join, and we interpose the tables.
It turns out that all our conditions are related to the first table only, so this is the only table that remains, and the query becomes much simpler for perception. One parameter is compared with case ID column twice from different tables. We can suppose that one comparison is extra. Let's speak about business logic. MD receipt is a table of prescriptions, and these prescriptions are given to patients when they visit a doctor. Step ID is identifier of this visit, and also we have identifier of a medical case. A case includes a lot of visits. So the query checks that this prescription was given to a patient within the framework of the case and within their visit. Denormalization is used to speed up search. Both these identifiers are stored there. A more complicated check will be eliminated. This is an extra condition. Let's apply all these to the query. We need to remember to eliminate the committed code, and we do not need to leave extra brackets. Optimized query is fulfilled within microseconds, and it has no requirements, almost no requirements to memory. So when we understand business logic and use denormalization, the query is better, but sometime later the query is back. So this page now has 2 new columns. Computations are based on the procedures stored on PGL PGSQL procedures were like this. They used cycles. And after that, the results of iterations were combined in common result, but all of these could have been written on a simple SQL, but the developer decided to do it in a difficult way. I rewrote them with simple subqueries, and this query left the top. So if you can do with simple SQL, do not use stored procedures on PL and PGSQL. So with simple actions, we improved several subqueries. I can give you several recommendations regarding these cases. Make readable what you need to read. Remove everything that is redundant. Check writings. Reduce queries number. Filter everything as early as possible. Use all the knowledge you have. Play with CTE and please experiment. Don't be afraid of experimenting. This was a simple presentation about improving a query. So we have several minutes for questions. If you have a question, you can raise your hand. We will give you the mic. Yes, please. Hello, thanks a lot for your presentation. And it was obligatory to remove brackets. Why? For the query to be readable, it doesn't have any impact on performance. Of course, it doesn't have any impact on performance, but it influences the readability of a query for a specific person. Thanks a lot for your presentation. I have a question about the fields that you removed, saying that they are not necessary. Why aren't they necessary? And why did ORM pulled all these fields? I didn't say that they are not needed. I removed them to localize the problem and to find it. After that, I returned them and I inserted the changed query into the common query. Okay, thanks. Can I ask a question? Yeah, I'm here. Thanks a lot. It was really captivating. My knowledge was not sufficient when you inserted new value into not. Could you tell me about this method? There was a link with the table yes from main. So you're speaking about core lease. It had two subqueries. Each of them had one entry selected because every subquery should return one entry. Only the first one selected the main contact or diagnosis, and the second one selected everything that remained. So it was not about variable, it was about sorting order by not yes. In the beginning we have false, after that true. It's not null, that's why we did not analyze null. That's why we added not from main. So it was possible to substitute it by disk. No, in that case, first of all, not main would go. Okay, I will read something about it. Thanks. Hello. Thank you for your presentation. I have a question. ORM. Did you manage to make it do left join instead of right? No, it was not feasible. It works just as fast, but it's not readable for a person, at least for me. Maybe someone writes right join, but I am used to left, so optimization took place inside. Yes, I wanted to show you the way we get to the problem, but maybe it was redundant. Thank you. It was really captivating. I would like to ask one more question. How can you collect statistics about the total time? Well, we use PGBudger. This is log analyzer. Within specific period, when some problem appeared, it analyzes the query, or it is done for prevention. It checks what reports were most frequent, and it also looks at the average and maximum time of implementation. Thank you. All these actions did not have any significant impact on the speed, apart from the last one, or you didn't measure it, but by the results of the final complex. Well, initially, my presentation did not include any slides, and after each action I measured the speed of implementation and I compared the things that improved or worsened, or maybe nothing changed in some instances. And here I decreased it just to be in line with the agenda. But it's quite interesting, the impact of every action. Well, in the first query there were a lot of small issues, but in the second and the third one there were specific transformations. Hello. Thanks a lot for your presentation. I have a bit different question. In the end, you always say that you amended something, but as I understood, developers write this. Could you tell me about your experience of influencing developers? You know, everyone can find some faults in code, but what can you do after that? I am a developer. Oh, okay. Hello. Maybe I missed this information. What was TPS in chain transaction per second according to PGTOP, or maybe you used a different utility to assess the load on the base. In the beginning of my presentation I said that I didn't want to complicate it, not to frighten off developers. You know, your question is really complicated. Well, I understand, but writing statistics on PGBudger queries is quite expensive. If you write everything in log, then TPS is quite interesting for me. No, I do not write everything in log. There is a specific duration normally, and only the values that exceed specific number of milliseconds are analyzed. Hello. Thank you. Thank you for your presentation. I would like to comment on it. As best practice for subqueries that have only one table, you recommend to delete ALS. And I do not actually agree with it. In my opinion, the best practice is to write errors in all tables. If this is a subquery, then most likely there will be an overlapping of names, and if a column is deleted, it will pull another column. Well, by default, column from specific table is taken, and only after that it is taken from the common query. If it is dropped, then in our system this is prohibited. A column cannot be deleted, but if a column is deleted, it can result in some problems. Yes, I agree. That's why it's better to write them. They do not complicate code significantly. Well, in that case, it's better to write shorter ALSs, and you know, there was no sense in it. In the first subquery, we had one ALS, and in the second one, we had another ALS, so it's like they were afraid that they will overlap. There are a lot of details here. Well, I think that we ran out of questions. Thanks a lot for your presentation. A round of applause for our speaker, please. And now you can have lunch.